Alright guys, now I want to talk a little bit about example number 3. I don't have the page number in front of me, but example 3 kind of touches on the idea of, okay, we have an x value and a y value. Which one do we choose and why? And they give us an example. The first example they had was they had somebody who was they had a bunch of books on their shelf and they wanted to predict they wanted to be able to predict how wide the book was if they knew how many pages the book had. So if they knew the number of pages, so the x value is kind of, okay, I know what my number of pages is, I'm going to put it in the formula for whatever it is, and then the number that comes out, after I do the math, the number that comes out will be my predicted width of my book. So in this case, the pages is the x value and the width is a y value. In this case, you could also switch it around and you'd say, okay, well, if I know the width of the book, I can have some other equation where if I know the width, I can plug that in, and then I do the math, and the number that comes out is the predicted number of pages in that book. And it's kind of hard to see which one you would need to know first. I mean, you can kind of argue it both ways. If I know the pages, I can guess the width. If I know the width, I can guess the pages. In this case, it's kind of hard to tell. I will say this though, the correlation coefficient for each of these relationships, we switch the x and y values, but the correlation coefficient, the r value, would be the same in either one of these situations. You can try it if you want to, but because the strength of the relationship is still the same. What would change though is like the numbers in the formula, so like or in the equation. So the slope might be different, and the intercept might be different. But the r value, when we do the math in the calculator, the r would still be the same because the relationship is still the same. It would have the same strength, whatever that strength is. Now when it comes to choosing which should we use for x or y, this is kind of what we got to think about here. We need to know what x is first. So once we have the x value, then we can plug that in and then we can find the y value. So sometimes you can kind of think about some situations where you might need, like in the example of the car, when I think about the car example, let me get that page back out again. In the car example, it kind of makes sense to know, okay, if I know how old my car is, I can kind of guess what the value of it is. That sort of makes sense to me. If I know the age first, then I can kind of figure out what the value is. That kind of it flows a little better. The pages and width is not as clean cut. But in general, the way we look at it is, since we know the x first, the y value kind of depends on x. We don't know what y is until we know what x is first. And so that's why my favorite way to label these variables is y is the dependent variable. So y is the dependent variable and x is the independent variable. There's some other names for these variables that are given to us in the book. There's a little table actually on the bottom of page 154, if I'm right. But on the bottom of page 154, it gives us like kind of three different kind of examples for names we can give to them. One of them being dependent and independent. Some values, some names for x is the explanatory variable, and another name for y would be like the response variable. That's some kind of popular names for that. But go ahead, and now that we have this information, go ahead and try out on page 175, number 435. It gives us a couple scenarios, and we're asked, okay, which would you choose for x? Which would you choose for y? So take a look at those, kind of see if you can figure out, what makes the most sense. What would be the most sense if we need this information first, and then we'll use that to come up with the other information. All right, so give that a try, and let me know how it comes out.